Alright, my dear. So in this video tutorial we'll learn about Nusselt number, prandtl number, Reynolds number, grashoff number, and Biot number. All these numbers are most important, as you know that. That's why I'm sharing with you. And if you learn these numbers, then these numbers are most important for competitive examination, just like it. I mean, most of the time they ask formula, as well as if you are preparing for any other examination just like JE, then even you are going to get questions from these numbers. And I did analysis. Most of the time they ask question from all these numbers. So let's get started from Nusselt number. So what is basically Nusselt number? So basically, if you prepare for, if you are preparing for convection, then this number is most important. You will definitely get this number. What is it and how is it? What is the formula of it? You will need to know. So basically, formula of this is S delta upon K, and delta is known as characteristic length. Basically, characteristics length. H is heat transfer coefficient, and basically heat transfer coefficient, that is H, heat transfer coefficient, and its unit is watt per meter square centigrade. Okay, now other than this, K is thermal conductivity. Okay, so this is all about Nusselt number. Now interesting fact is that with prandtl number is formula is nu upon alpha. Nu is known as kinematic viscosity, alpha is known as thermal diffusivity. So you can say it is the ratio of kinematic viscosity to the thermal diffusivity. One another formula, one other thing or another way we can learn or we can come to know its ratio, that is molecular diffusivity of momentum to the molecular diffusivity of heat. So diffusivity is a most common term for this case. So basically nu is known as kinematic viscosity. So what is kinematic viscosity? That is, kinematic viscosity is equal to dynamic viscosity by rho. Rho means density here, and alpha is thermal diffusivity. Its formula is K by rho Cp. Okay, conductivity by heat capacity. Rho Cp is known as heat capacity. If we'll do some calculation or simplification, then what we are going to get, just let me share with you. Rho and rho Cp K, sorry, this will go up, so this will be rho Cp by K. So rho cancel, the remaining will be mu Cp by K. So this is the formula for prandtl number, right? Now let's move to the Reynolds number. Well, most of the time people ask about Reynolds number, because according to this number we can come to know the fluid is what type of flow the fluid is exactly: laminar flow, transition flow, or even turbulent flow. So that's why the application of Reynolds number is quite wide. Okay, now the formula for Reynolds number is inertia force by viscous force, and it is known as, also we know about it as rho VL by mu. Okay, so basically what is rho? Rho is density, and V is velocity, L is length, that is characteristics length, and mu is viscosity. Okay, now if Reynolds number is about 2000, then it is known as, then flow is known as laminar flow. If Reynolds number in between 2000 to 4000, then it is known as transition flow. If Reynolds number is above 4000, it is known as turbulent flow. Basically such type of things we studied in FM. Okay, such type of things we studied in FM, fluid mechanics. Because if you are talking about fluid flow, then we usually study fluid mechanics. In that case, we know, or we studied about it, what is laminar flow, what is transition flow, what is even turbulent flow. If you are asking for example of turbulent flow, then I must say smoke or cigarette. That's the real example of turbulent flow. So this is all about Reynolds number. So till now what we have studied, Nusselt number, prandtl number and Reynolds number. These three numbers are really important. Now what we got, the next number, that is known as grashoff number. So the formula for grashoff number is buoyancy force divided by viscous force. There is little difference between inertia, Reynolds number and grashoff number. In the division we have viscous number both, but on the upper side inertia force is for Reynolds number and buoyancy force is for grashoff number. So so what we got here, G beta Ts minus TL T infinity LCQ by nu square. Now you can see nu is kinematic viscosity, LC is characteristics length, and Ts is surface temperature, T infinity is temperature far from the surface temperature, and G is gravitational force, or gravitational acceleration due to gravity, acceleration due to gravity you can say, and this is beta is coefficient of volume expansion. This is all about grashoff number. Now all these numbers, after all these numbers, at the end we are studying about Biot number, because I have seen questions they have asked in the case of prandtl number, right? Alright, so let's study about Biot number. Biot number is, its formula is conduction resistance to the convection resistance. Conduction resistance to the convection resistance. Well, I cannot remember in which book I have, or probably in the examination I have seen, they have directly asked the question from this topic, that is Biot number. They have asked, just simply asked, what is the ratio for Biot number, that is conduction resistance to the convection resistance. They have given multiple options, just like convection resistance by conduction resistance, then conduction by convection, or both, or maybe any other option, and another option was, I think, none of these. So based on this they have asked the question, but here the formula HLC by K, the formula for this Biot number is HLC by K. So H is what, heat transfer coefficient, LC is characteristics length, and K is because of thermal conductivity. So here, as you can see, this is for conduction, that is K, this is for convection, that is for H. So basically these two terms we generally study in case of Fourier's law as well as Newton's law of cooling. I have already shared with you. Let me share with you what is that. How we are relating this convection and conduction. Actually, if we say in broadly, in case of conduction, well, this is one of the mode of heat transfer. There are three modes of heat transfer we have studied. One is conduction, another is convection, and last one is radiation. So in conduction we follow Fourier's law, right? We follow Fourier's law. In case of convection we follow Newton's law of cooling. Newton's law of cooling. So in case of Fourier's law we follow this Q equal to minus Ke dt by dx, and in case of, let me share with you. You can see right now. In case of Newton's law of cooling we follow Q is equal to Ts minus Tf. So T is surface temperature, Tf is fluid temperature, H is heat transfer coefficient, A is area, and here K is thermal conductivity, A is area, and this is known as temperature gradient. This is difference in temperature, and this is a width, you can say, right? Maybe sometimes we call this thickness also, right? So basically based on these two formula we studied, or we solved further things in these. Basically, so what we studied, we need to know its basic concept of conduction as well as convection. These two formulas play most important role. You must remember this. So what we have studied till now in this tutorial, we have studied Nusselt number, we have studied prandtl number, we have studied Reynolds number, we have also studied grashoff number as well as Biot number. So one interesting fact is that all these numbers are dimensionless. Remember that all these numbers are dimensionless. They don't have any dimension. So one fact is that. Now, another fact, if you'll ask which one is most important out of all these numbers, then I must say one is prandtl number, another one is Reynolds number. Most of the time people, or most of the time in the competitive examination, we have seen question from prandtl number as well as Nusselt number. So don't forget to understand all these numbers, because it will take less than even 1 minute. I mean, not 1 minute exactly, at about 50 minutes or 1 hour. If you study for 1 hour, definitely you can crack the question. Well, thanks for watching. See you soon in my next video. Bye bye.